Hello guys, welcome back to the Problems video. Today we will be having a question here from the COMC 1998. It's the third question from part B, and as always, let's first start off by reading the question. So, triangle ABC is right angled with its right angle at A, and the points P and Q are on the hypotenuse B, such that BP equals PQ equals QC. So, if AP is going to be equal to 3, and AQ is going to be equal to 4, determine the length of each side of ABC. Now, I've already drawn the graph here. There was supposed to be a graph for the question, but I didn't get it, so I just drew it out myself. And whatever's labeled in red is given to you from the question. So what are these? Well, black symbols. So A here, pi minus theta, B, C. What are these? Well, these are the variables that I've set so that we can actually solve this problem. So let's first look at, and this is cosine law here. Let's look at this angle here. So pi minus theta. You can see that cosine pi minus theta. According to sine law, actually I'm gonna write it somewhere else. So cosine pi minus theta, right? This is going to be equal to 3 squared plus a squared minus 4 squared divided by 2 times 3a. So if you don't know how cosine law works, how it works is that cosine for whatever angle is going to be equal to the sum of the squares of the adjacent sides, so 3 squared plus a squared minus the sum of its opposite side, or its respective length. So that would be 4 here, 4 squared, and it's divided by 2 times the two adjacent sides, the side lengths multiplied together. And now we can further simplify this into just a squared minus 7 divided by 6a. And something you need to know here is that cosine pi minus theta is also just going to be equal to negative cos theta, right? So now let's look at stuff like AB. So we're going to do cosine law again here. We can see here that for AB, so that AB right there, we can see that AB squared is going to be equal to a squared plus 9 minus 2 times 3a times cosine theta, and this is going to be equal to a squared plus 9 plus 6a times a squared minus 7 divided by 6a. So if you're wondering what I did here, as I said before, cos pi minus theta and cos theta, they're equal to each other, but there's just a negative sign in between them. I'll make that a little bit more clear. There's a negative sign in between them. So I just plug that in here, then I obviously have to swap the negative sign here for a plus, and then we plug it in. And this can finally be simplified. We can just get rid of b6a down here, and after that we can obviously do everything we need to, and this is going to be equal to 2a squared plus 2. So now I think we should go look at AC. Now we can see here that AC squared, similarly to before, we're just going to use cosine law again, except we're going to use 2a here, so PC, PA, and AC is a triangle, and we use this angle here. So as I said before, pi minus theta. So no more of this negative cosine theta stuff. We can just plug it directly in. So this is going to be equal to 4a squared plus 9 minus 2 times 3a. Sorry, no, 2 times 3 times 2a this time, times cosine pi minus theta. And this is going to be equal to 4a squared plus 9 minus 12a times a squared minus 7 divided by 6a. And this being further simplified, obviously this is 6a here and 12a here. We can obviously simplify that into 4a squared plus 9 minus 2a squared plus 14, and this is going to be equal to 2a squared plus 23. So why did I just solve all of this? Like, what's the purpose here? Well, we can see here that this is a right angle triangle, and we know that BC in terms of A is 3A, and now we know what AB and AC are, both in terms of A. And since we know what AC squared is and AB squared is, and since Pythagorean theorem, because this is a right angle triangle here, we know that BC squared is going to be equal to AB squared plus AC squared. And because cosine law uses the squares of side lengths, it's pretty easy here. We just need to add these two together, and we know it's going to be equal to 3A squared in brackets. So, AB squared plus AC squared is going to be equal to BC squared. So, 2A squared plus 2, so that's AB, plus 2 squared plus 23, that's AC, is going to be equal to 3A in brackets squared. So we also need the square root of 3 in there as well. And we're going to add these together, so simplify it. 4A squared plus 25 is going to be equal to 9A squared. And this means that A squared is going to be equal to 5. So A is going to be equal to square root 5. And because A is equal to square root 5, we can simply plug this in back into these three equations. And then after that's square rooted as well. So this is how I receive that AB is going to be equal to 2 times square root 3. Make sure you square root these after, because these are the squared versions of them. AC is going to be equal to square root 33. BC is going to be equal to 3 times square root 5. And that's it. Thank you guys for listening. If you have any other way to solve this problem, please let me know down below in the comments. And thank you guys so much for listening. Bye.